Go,
Hello,
go.
everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Joel, Seth's brother. We're here to hopefully show you how to approach studying for the Math SAT and also how to approach actual SAT math questions. So, the first thing is how to approach studying for it. Well, there are many ways to study for it. One great way is to go through the Khan Academy practice, because the Khan Academy has partnered with the SAT people, and they basically are telling you what's on the test, and they're giving you practice questions for what's on the test. If you want to see how to get to these practice questions, watch our video from June 29th of this year, 2023. So today we are going to move to advanced problem solving. Notice the problem solving comes in all of those, both foundations, medium, and advanced. Foundations are the basic stuff. Okay, so we're going to go to problem solving today, and we're going to try the first question in the first topic in problem solving, called ratio, rates, and proportions. Okay, we encourage you to do if you're not sure how to do the advanced questions, then go back and do the medium questions. We're only doing the advanced questions with the idea that if we go show people how to approach the math and advanced questions, presumably that'll work for the medium questions. Okay, without any further ado, here we go. We're just starting this for the first time. Let's go. Okay, please, everyone, read the question, pause it, and come back, and we'll try to do it. Okay. Commercial real estate developer creates a scale drawing of a commercial property that he hopes to sell. I gotta do annotation, right? Annotation. Okay, property, right. Okay, the ratio of the area of the drawing to the actual area of the commercial property is 1 square foot to 900 square feet. The developer hopes to sell the commercial space for $1.8 million, which would be equivalent to $1,000 per square foot of the property's area. To the nearest square foot, what is the area of the scale drawing? Okay, so there's a lot of ratios here. It's not just a simple one ratio problem. And units will help us, lead us to make sure we get the right answer. Developers to sell the commercial space for $1.8 million, which would be equivalent to $1,000 per square foot. To the nearest square foot, what is the area of the scale drawing? Well, in order to get the area of the scale drawing, we need to know the area of the whole thing, right? And once we know the area of the whole thing, the area of the big thing, then we can immediately get the area of the scale drawing, right? So
Right.
I like to do these problems. One approach to do these problems is to do them backwards. Okay, first we do backwards. So first we need to know the area of the big thing. So how do we get the area of the big thing? The developer hopes to sell the commercial space for $1.8 million, which would be equivalent to $1,000 per square foot. Oh, wait, so that gives us the area of the big thing, doesn't it?
Yeah.
Yeah, that gives us the area of the big thing, yeah. Yeah. So if he wants to... Right. In other words, right, exactly. It's 1.8 million divided by 1,000, or the number of square feet of the big thing. Using the unit analysis, $1.8 million per square foot gives you what Seth said, but the units are important. The units here in the numerator are dollars. The units in the denominator are dollars per square foot. So using unit analysis and that complex fraction thing, where you divide one fraction on top of another, this is dollars divided by 1. So this is dollars divided by 1 times feet divided by dollars gives us feet. Yeah,
Okay.
exactly.
It's not feet, it's square feet.
Square feet, yes.
Which I wrote in for you.
You're right. Sorry.
There's a little 2 over there.
Yeah,
See,
you're
it's
right.
square feet.
You're right. So this is what we got. This is what we need. We need the area of the big thing. And if the area of the big thing is 1,800 square feet, then the area of the small thing is 2 square feet.
Yeah.
I mean, you can sort of see that,
Why
right?
not? Yeah.
But let's not
Because there are
cut
two
corners, right?
900s. There are
Right.
two 900s and 1800.
That's right. So the scale is 1 square foot for the small, 900 square feet for the big, equals x feet squared for the small divided by 1800 square feet for the big. And then you solve for x, you realize that x is 2. Yeah. So this includes easier, less advanced ratio problems. In other words, just one of these parts would have been a easier ratio problem if it was just that one question by itself. But here they're combined 2 ratios.
Well, what's this clutter? What's that? The thing I circled?
1800
Oh.
square feet. Let me see, can I go to an even finer one? 1800. Maybe I'll, not to upset Seth, maybe I'll go to even a finer.
No. I think the deal is what you do is it says no.
Right. Okay. You mean write it a little slower.
Yeah.
Write it a little slower.
No. Yeah, you don't try to write it slowly, deliberately. ELIBRATLITY.
Deliberately? Okay.
Yeah.
I think that's misspelled.
Of course it is.
Yeah.
Yeah. Okay, that's easy to notice. Yeah, so it really didn't matter that the 1800 and the 900 were square feet and square. Yes, they were units of you. They were all units, and there's a conversion of one small unit to 900 big units. Yeah.
Right. Yeah.
Now this problem does not involve the much more tricky issue of that as follows. If the scale of the drawing is 1 square foot of drawing to 900 square feet of property, what is the length scale? What is 1 foot in the drawing?
Right, but that wouldn't be, well, that, to be devil's advocate, that wouldn't be necessarily a question just on rates. That would be a question of geometry.
Well, it's a ratio. It is.
No.
Yeah.
Wait, are you talking about the scale?
Scale. Yeah.
The scale versus the area.
Well, there is a scale. They express the area in terms of area ratio.
Right.
They express the scale of the drawing in area ratio.
Right.
But what is more common in annotating of scale drawings is length ratio.
Right, and how that relates to the square area. Yeah, but that's a geometry question.
That's a different question from this, but it's a question, could it be on the SAT?
Well, probably. You should definitely know it. It's definitely taught in geometry class at the, but grades less than those that take the SAT. But that's a geometry question.
Let's draw a picture.
How does the area scale?
Here is a drawing.
The area of the scale of the dimension of the lengths. And
this drawing is 1 foot wide and 1 foot tall.
Right.
The actual building is bigger. This, what's inside the drawing, is 1 square foot equals 1 foot square.
Right.
Inside the house, there are 900 square feet.
Right.
Now, what is the length and width of a square whose area is 900 square feet?
Yeah, be 30 by 30.
Well, that is 30 feet.
Right.
By 30 feet.
Right.
Okay. So the length scale, 1 foot on the map, on the drawing, equals 30 foot on the building.
Right. Yeah, but they're not asking for any of that.
Okay.
That's not part of the problem. We're just going.
Well, when you watch this video, now you're also ready for a problem where they'll ask about that issue.
Right, but that issue is more taught where if the length of scale drawing, if the ratio of the lengths of a square drawing are 1 to 6, what is the ratio of the areas? Well, the areas are 1 to 36, and the volumes are 1 to 6 cubed. So the areas go as the scale of the length squared. The areas go as the scale of the length squared, and the volumes go as the scale of the length cubed. That's more of a geometry thing, but we'll probably see that in the geometry questions. But yeah, we can easily, I guess we could see that here. But right now, they're just going for ratios. But this is a double ratio problem, isn't it? We may be able to do this through unit analysis in one shot, but we probably could. We probably could.
Yeah.
But it's sort of easier, I don't know.
Is the wash ready?
One approach.
One
approach to do it is to do it in 2 steps. And also, I think it's a great idea. I mean, I personally like to do things backwards. Realize what you need to get this answer, and then figure out how to get what you need here. Do you think it's practical to do this as a unit, using unit analysis with one long ratio?
Yeah. Sure, why not?
Should we try that?
Yeah, let's try.
Okay.
Yeah.
Let's try to do it. Very often when you have to do multiple multiple ratio problems, it's helpful. One way to do it is to use unit analysis and just write it out. So this time I'll try to be really neat. So what are they giving us? Oh no, but they're giving us, what do you want the answer to be? You want to know feet squared big, right? Right?
No,
So-
you want to know the area of the scale drawing.
Yeah, feet squared small. Feet squared small.
Yeah.
So we want feet squared small, and we know the ratio of feet squared big. Right? We know that. That is 1 to 900. Now, if we want to knock this out, we need to know feet squared big. Okay, so how are we going to get feet squared big? Feet squared big, isn't that equal to dollars per, no, dollars, wait, dollars, which we know is
Draw a dollar like that.
1,800. Now, we want to put dollars in here. No, let's do it this way. Let's put the dollars in the denominator so we don't have to use complex fractions.
I did
we
put
want to know
dollar.
dollars per feet. No, dollars We want the dollars.
You have 1,800,000. Divide that by the number of dollars per square foot big. That is equal to the amount of square foot big.
Right. That's equal
And
to the
then
amount of square
this,
foot big.
so this thing is what's equal. This gadget is equal.
Yeah, right.
To,
right.
So what you want to do is take this quantity. Look, what is this?
Okay,
Yeah,
first
good.
of all,
Thank you. Erase it. Yeah, and that 800,
1,800
yeah,
dollars.
per.
But wait. We have to use complex fractions. Why do we do this?
Complex? What's wrong with complex fractions?
Because complex fractions make things complex.
No, complex fractions means you have a numerator and a denominator. And what's wrong with the denominator being a fraction? That's what the problem is about.
No, because it's easier if there's no.
It's easier to write things as they are. The ratio is dollars, of course,
right,
to dollars per square foot. So dollars per square foot should be in the denominator.
Okay.
So what if the unit is a fraction?
Fine. So this is dollars per foot squared, and this is 1,000.
Yeah.
Oh, this is big. Right.
Yeah.
So then what happens is after you do the complex fraction thing, this feet squared big becomes in the numerator, and then it crosses out with this one, and then you're left with dollars out of here, and then you're left with feet squared small. And then
so to deal with complex fractions, you just need a rule.
Yeah.
Called N over D divided by N2 is a rule when there is a quantity in the denominator of the denominator. It's the same as when you move it to the numerator of the whole thing.
Right.
The reciprocal of a reciprocal is the original thing.
Right. Okay. Typically, also complex fractions are also shown. Let's say A over B is over C over D is A over B times D over C.
Yeah.
Same idea. Okay.
So the D over here went to here.
Yeah.
And the D over here went to here. And this thing should be get a real equal sign.
So there were two approaches here we offered. One was do the problem in two different steps. Think maybe the problem backwards, and then we also did a unit analysis way of doing it as well. Let's see how they did it. Okay, so the answer. Oh, look, show calculator. Oh, they don't give Desmos. They don't give a graphing calculator, do they? Oh, but on the digital SAT, they're going to give you a graphing calculator. So I think that the answer is 2. Okay. And then let's see how
they agree with us.
Yep. Let's see how they answered it. Okay, so they did it in 2 ratios, but since developer hopes to sell that, we can set a promotional number of square feet. As notice, they didn't think of it backwards. They didn't introduce the idea as to why you're even doing this. Like, why even do this, right? So that was what I thought was helpful, is that the reason why we're doing this is because we have to locate this number. We have to locate S.
So they introduced a unknown S.
Right. which is the big area.
The square feet of the property.
The square feet of the property, yeah.
As
Yeah, right. Also, they didn't use units here. That's a little disappointing, right? They put units here, though. Give them credit for that. They also used units here. Give them credit for that. So very similar. I mean, they did it in 2 steps.
Well, what they did here was actually, yeah, they were the formal units are square feet per square feet, which is a pure ratio. It's because it's a ratio of areas.
Yeah. Yeah.
One area to another area is the ratio of 2 areas is independent of the units used to represent the areas.
Right. But they also could have said big and small, right?
Yeah.
We did. Like we were careful with this. We did 1 square foot big over 900 square feet small. We made that distinction, which I think is really helpful in these problems.
Yeah. What they didn't do is okay. What they wrote here. Here's what they wrote in English. The ratio of the area of the drawing to the actual area of the property.
Right.
Okay, there's an is there.
Yeah.
Well, let's the is an equal sign.
That's right.
1 foot squared colon 900 foot squared is this colon. This silly tab. This this colon is a fraction bar.
Right.
Come on.
Yeah, it's a ratio.
It represents
a
ratio. Is a fraction.
Represents a ratio. Yeah.
Yeah. Is a 1 foot squared ratio to 900 foot squared. And then the is, this is the ratio. This is area ratio, area of drawing, ratio colon area of property.
Right. Yeah.
You see the colon.
Right.
That's the same thing as a fraction bar.
Right. Yeah, so
and is the same thing as equal sign.
Right.
And so so instead of writing ratio area of drawing to area of property, I write
right
area of
drawing. Yeah, divided
ratio
by
fraction area of
right. Yeah, I don't think that really leads to much confusion, but it is good to justify it.
Yeah. Now, and then they tell you that the scale of the drawing, the area of drawing divided by the area of the property is 1/900th. One
Right.
divided by 900.
Right.
Yeah.
Yeah. Yeah. Yeah.
Yeah.
Okay.
Okay.
That's fine. Okay. I think we're done.
Yeah.
Yeah, I think we're done.
And
Okay.
then the formula
No,
they
I guess
got
not.
here
We're
is
not
the
done.
D. D. What is D? D is the area of the drawing,
Right.
and 1800 is the area of the property.
Yeah. So then you just write D.
So they put into the area of the drawing is the unknown.
Right.
The unknown D, and the area of the property is given. Is the given in the problem as the answer from step 1.
Yeah, so the thing, the bone I have with this type of answer is that if that's what they're originally looking for, the strategy, if I was going to write this up, I would first write step 0, which would be the strategy. The strategy is, we need to find D, so I would define D first. In order to find D, we first have to find the area of the big property, and then we do it this way. I would always start these problems with a strategy before you start going into it.
And absolutely,
and
yes, completely
terms,
important idea that you should start and keep in mind what is the question.
Right, the strategy. When you're doing problems...
So first you need to know the question.
Yeah, obviously. Okay.
Then, no, not obviously, because a lot of kids don't start with answering the question.
Right. You need to... You're absolutely right. First you have to know what you need. Yes.
What is the question? Then second, find a strategy for getting an answer to the question.
Right. That's right.
Now, that strategy often includes finding an answer to a different question.
That's right.
Where the new problem has an answer that contributes to the answer to the original problem.
Exactly. That's exactly right.
So that's what a strategy means. Right. To figure out new problems that can be solved because the information is given directly, and the new problem helps solve the original problem.
You said that's right. Yeah. So this is a 2-step problem, and that's probably why it's an advanced question. Because anytime you have a word problem and it doesn't seem really easy, like really obvious, like your apples cost $6 each, you buy 3 apples, how much does it cost? If it's not an incredibly easy problem, the chances are it's a 2-stepper. And with a 2-stepper...
Well, if it's even more typical, it might be a 3-stepper.
Yeah. So in these problems, the strategy is really important. And that's my bone with answers in general, is that the answers are not... When people write up the answers, and hopefully when teachers teach us, they talk about the strategy first before they start going in and start solving. But please, we highly encourage you when you approach problems like these to think of the strategy first and then do the problem. So, okay? Anything else?
No.
I think so.
Yeah, think of what is the question first?
What is the question
Second,
first?
What is the strategy?
Right.
Yep. And then 3, follow the strategy.
Right.
And then 4, check your answer and check if it is reasonable.
Exactly. Totally makes sense. 2-foot, if you came up with a 3,000 square foot model, that would be crazy.
3,000 square foot drawing.
Yeah, that would be insane. That would be insane. That would be obviously wrong. Yeah. That's exactly how you do these problems, exactly how you approach these things. Good. Hopefully this helped the listeners. If you survived already 29 minutes, we're a little long today, but this approach is really important. Okay, everyone. I guess that's it, right? We're done. Okay, have a great day, and hope to see you tomorrow. Please like us, dislike us, give us comments on our YouTube videos, and email us your SAT math questions at satmathquestionoftheday@gmail.com. Okay, everyone. Have a great day. Bye.